Hi, everybody. Welcome to our March Oculus AMA live at GDC. I'm Allison Lee. I'm part of the developer ecosystem team here at Oculus. Last year, my team started the Oculus AMA series to give VR developers a chance to voice their questions and connect directly with members of the Oculus team. Typically, we host these AMAs on our Oculus developer forums, but since it's GDC, we thought we'd shake it up a little bit and host this session live on the floor. So today we'll be taking questions live from you in the audience, and also just to make sure that we're taking into account members of our community not at GDC this year, we'll also be answering questions from our social channels, from our forums, and also sourced from our Oculus Start program. And speaking of social and our Oculus Start program, if you haven't heard, Oculus Start was launched earlier this year for new VR developers with an existing build who have just entered the ecosystem and need a little bit more help to get their app moving. So if you would like to join Oculus Start or you would have any questions about the program, you can visit our website. It's developer.oculus.com/Oculus-Start. You can email us at oculusstart@oculus.com. Or if you're here at GDC, please find anybody in these Oculus Start t-shirts. We have Rita here and members of the developer support team in the audience. You can ask any questions and see if you could qualify. Also, a quick reminder that we are on social, specifically for our developer community. These channels have information about new tech updates, insights from the community, and also will keep you up to date on anything AMA-wise. So the next one will be announced on our Twitter channel at Oculus Dev or our Facebook page at Oculus_Dev. All right. So let's get this show on the road. Today, we'll be joined on stage by Chris Pruett, our head of development engineering. He's here to answer your questions. So Chris, would you like to introduce yourself?
Sure. Thank you very much.
You're welcome.
Hi, my name's Chris. As Allison just said, I run our developer engineering program. It's actually our developer relations engineering program. And that what we are is we're basically a bunch of, pretty veteran game devs. And our job is to work with folks like yourselves. Our job is to basically work with third-party developers who are building in VR for any of our various VR products. And we do a lot of, optimization, bug work. We do any kind of like VR design, anything we can do to help you be as successful as possible on our platform. That is kind of my role. I like to drop in, try to solve problems, and then get out of the way and let you make your games. So today, I thought what we would do is we got a bunch of questions from social media already. I think we're going to start with, and I'll do my best to answer them, and then we can open up to the floor.
Awesome. Yep. Sounds good. Before we get going, it's a little bit of AMA tradition, Chris. Can you give us a fun fact about yourself that no one else would know?
A fun fact about myself that no one else would know. See, you didn't prep me for this one. I didn't know what I was going to say. I could do a really good handstand.
Really?
I'm a really good handstand.
Well, I think our setup team would cringe at me if I asked you to do a handstand on stage.
This is probably a violation of our self-improvement.
Find him later and ask him for a handstand. All right, so let's get started with our first question. Our first question is actually from one of our Oculus Start members. He read your first two blogs about mobile optimization and would like to know if you had any tips for new devs looking to improve their performance out of their titles, and specifically if you had any thoughts about any new room to play with the number of draw calls for mobile apps.
Sure. So the blog post that they're referring to there is something that I wrote maybe 2 or 3 years ago. So it's actually fairly old now. I think the highlight of the tips that are in that blog are basically right, but the numbers have changed because the phones have gotten faster, and we know that the software has actually gotten better. Generally speaking, if you're building for mobile, which for us means Gear VR and now Oculus Go, you probably want to be less than 200 draw calls a frame, and that number is just a rule of thumb because the actual cost of a draw call is really dependent on what it is you're drawing. The way the GPU works, the way the GPU driver works on the CPU is that when you bind your mesh or you bind your shader, the first time that you do that work, it has to do a bunch of work to actually convert all that into a format that the GPU can understand. But if you were to draw the same thing a second time without changing the state, the second draw call would actually be very cheap because the state is all cached. So when you say, like, oh, it has to be n draw calls, that's actually not a very nuanced answer because the total number of draw calls is kind of dependent on what the draw calls are. But generally speaking, what we see, like with Unity projects or with mobile games, is that you'll have, a draw call for one thing, a draw call for something else, a draw call for something else, and those usually don't share a lot of state. The main recommendation here is to make sure that you batch your mesh really effectively. Like in Unity, that means using static batching, using dynamic batching, making sure that all of your objects are the same material, and then what will happen is Unity will sort of cram all those into a single giant mesh that will get bound once. The material for that thing, if you've atlased all your textures and use a single material will get bound once. You pay the expensive part for binding one time, and then you can draw a bunch of little objects inside that mesh independently without really incurring a high cost. So the recommendation of 200 also assumes that you're using multi-view, what Unity calls single pass stereo rendering, which is a modification to OpenGLES that landed in phones about the middle of last year. And it actually basically causes your draw call to apply to both the left eye and the right eye. Before multi-view, you'd issue all your draw calls to draw the left eye, and then you'd issue all your draw calls to draw the right eye, and that means that you were doubling all the complexity of your scene in order to just have a VR scene. So I would say, oh, well, you probably want to be at 100 draw calls per frame, and that meant 50 per eye, which meant you actually had to be really quite conservative. But these days, multi-view you can issue a single draw call and draw into both eyes. Best case, that's like a 40% performance improvement for draw calls. So practical case, maybe it's more like 30%. But these days, we can basically issue all the draw calls for the entire scene once and fill both eyes. So that means, in addition to performance improvements, some of which I talked about yesterday on Oculus Go, I think probably 200 is the upper bound. But again, it's very content dependent.
Okay, awesome. Thanks. Our next question is from our Oculus forums and is about light maps. So from a design and development perspective, what are your tips for devs looking to bake as much lighting into their game as possible?
Sure. So I've had a somewhat public relationship with light maps over the years, in that I think that light maps are a fantastic way to make your game look really good without actually expending a lot of time on draw calls or on real-time lighting. And for most games, whether we're talking mobile or PC, most of the time, most of the lights are not moving. Most of the shadows are not moving. Even if you have a flashlight or some other dynamic object that is casting light into your scene, most of your shadows are static. And there's really no reason to pay a real-time lighting cost unless you have some sort of very dramatic lighting system, like you have fireflies flying all over the place and they're all casting different shadows or something like that. So I think that in most cases, light mapping is the right way to go. And in particular, if you do your light maps properly, you can cut both the cost of your draw calls and the cost of your lighting really significantly. I think the best practice for that, whether we're talking PC or mobile, is you want to go with really large light maps. Like on Gear VR, I would tell you to use 4096 by 4096 light maps, which is much larger than you might assume. On all of our platforms, we have actually a lot of texture memory. We're not going to run out of texture memory. So if you increase the size of your light maps, what you can do is you can push more of the objects in your scene into a single light map, and that means there's less state to change as you're executing your draw calls, which means it's easier for like Unity or Unreal to batch your objects together, which means that you will have fewer total draw calls and it'll be an overall improvement. A light map is really just a texture blend when it gets down to the shader level, so it's very cheap to actually draw the pixel against the light map, and most of the cost is in the setup. I'll tell you the most recent light map setup that I did for a title was we took a bunch of disparate scenes, like we have different rooms, and this is a Unity project. Different rooms, and we want to work on each room as an individual scene, but we want light to like cast through doorways. Like we can click the scenes together and make, like a house, but we want the light to cast through doorways, and the light mapping in Unity is basically per scene. So there's not an easy way to make a multi-scene, environment share light maps. So what we did is we actually took these scenes and we built like a build script that clicks them all together into a single scene and then runs light mapping on that. And the nice thing about that is you can get light maps that cover more than one room. Right? You can get, maybe I have 10 rooms and I end up with 4 light maps because the light maps are very high resolution, which means I'm getting great coverage. And I have to switch light maps as few times as possible when rendering that scene. So that entire build setup, would not have been necessary if I wasn't interested in optimizing my draw calls by optimizing my light maps. But we built it in order to be able to do that.
Awesome. So before we get to our next question, if you have any questions on the show floor, please come up and let me know your question. We don't have a handheld mic right now, but I can read it out for you, and we'll get them answered by Chris. Awesome. All right. The next question we have is actually about occlusion culling and your custom tech.
Oh, okay, sure.
Any chance that'll be released for devs?
So this question is referring to some occlusion tech that I wrote for another project. Just to back up and talk about that a little bit, occlusion culling is a generalized system by which you only draw the meshes that you can see. If you think about the case of, like, say, again, standing in a house. If I'm standing in a house and I'm looking at a closed door, there's no way for a general purpose 3D system like Unity to know that the room beyond that door is not actually visible. What it was going to do is it's going to go ahead and decide all of that's in the camera frustum, and all of it might need to be rendered because we don't really know what's in between, and it's going to start drawing, and it's actually going to issue draw calls for everything that's in that other room. And then we're not going to see any of those pixels because they're going to be killed by either depth or a depth test, or they might be killed by the if you're on a mobile GPU, the mobile opaque sorting reject system. So that's a waste, particularly if you're worried about draw calls. That's a waste because you can't see that room, and there's no way to actually see it, and there's no reason to draw any of it. So Unity has a built-in occlusion culling system that does this. It's called Umbra. It's actually a third-party technology that Unity integrates. Umbra is a very well-known veteran technology that's been in a lot of game engines, and it works really well. In Unity, the controls that you have available for it are pretty simplified, and so sometimes it's hard to control exactly what's going to be made visible and what's not. I've had trouble in Unity before getting like a scene that should be able to be made very, very efficient to be made actually as efficient as I think it can be using Umbra. Other folks have had better success. It seems to particularly work better for like outdoor scenes than it does for indoor scenes. But if you can use it, it's very convenient and it works pretty well. If you can't use it, you can always write your own occlusion culling system, and it doesn't actually have to be very complicated. You could be as simple as, if I'm standing in a trigger volume, then turn off everything that I know I can't see. Like turn off all of the objects in the far room until I leave the volume. And if I leave the volume and I open the door, then we probably have to turn those things on. But you could, if you wanted to, hand place, regions all over your world and say, from this position, here's the things I expect to be able to see, and just sort of turn things on and off. And if your game is small, or if your scene is constrained, that's actually not too much work. As your scene becomes larger and more complicated, you're probably going to want to automate that. And that's what I did. And I went through several different versions of it. The first version that I authored, it would assume that you're standing at a single point. You stand at a single point, and as long as you're at that point, I could figure out everything that you could see from that point. And my method for doing that was to render a panorama. I'd put the camera where I thought you were going to be, and I'd render like a 360-degree panorama, and I'd render it with a shader that colored each of the mesh a different color. And I remember they'd come up with some lookup between like the mesh color and the mesh pointer. So when I have this panorama image, I could walk over all of the pixels and be like, oh, this is like this particular red, which I know maps to this chair over here, so I know that I can see the chair, and I can put the chair into a visibility list. And anything that I don't see the pixels for means I can't see and should be occluded. And then I could come up with a list of geometry that was like what I can see from this point. And from there, I could just say turn everything off, and now turn on only the things that I can see. And as long as I'm standing at that point, I will only have those things on. It's a panorama, so it'll be things behind me that I can't see, but I can rely on frustum culling to take care of those things. So that was the first version, and that worked as long as you didn't move. But as we know, like, positional tracking is cool, and we want to be able to like walk around a little bit. And as soon as you start to move a little bit, the data that I've computed is wrong. Like, I'm occluding things from one point. But if you move where you're standing from, maybe you could see around a corner, maybe you could see behind that desk, maybe there's some object that you can see from another location. So that system wasn't sufficient. The most recent version of the system I have that does this is the same idea, except for one point, it will render from many different points. And there's some complicated pieces in here. You know, the frequency of points that you need to render from is a function of the complexity of the scene. So if you're in like a long hallway where there's not much there, you don't need very many points. But if you're in a complicated room with lots of little objects, you need a bunch more. As you move the camera through the scene, you have to have some way to figure out which point is closest and either interpolate from where you are to that or decide this is my current point and turn objects on and turn other objects off. There's some complicated cases like doors. If you open a door, suddenly you can see a whole bunch of stuff that you couldn't see before, and so you need to know what a door is, and you have to link the door to a point that says, okay, when the door's closed, this is what I can see, but when the door's open, this is a different set of stuff that I can see. Using that same approach of just rendering a panorama has worked pretty well for me for that. It's you know, all of the complexity has kind of flowed from that sort of basic design. There's a ton of different ways you could implement your own occlusion culling system if you thought you needed to. If you look up, if you want to research this topic, there's actually a huge amount of research out there. Lots of different solutions. You don't have to use the solution that I chose. The other word that is used if you're looking for like research papers is potential visibility set, a set of geometry that is potentially visible from our current position. So if you look up PVS, potential visibility set, or occlusion culling, this stuff is out there. It's been around for a long time. The one that to answer the question, I don't think that the version that I wrote is in a releasable state. My code's not that great. So probably the answer is, would I release it? The answer is probably no. Probably what I would recommend that you do is if you're in Unity, you should use the built-in one in Unity. But if you do want to do it that hard, you just have to decide to do it.
Awesome. So before we go to the next question from social, we actually have a question from the show floor. This is from Dylan Shaw. He's part of our Oculus Start team. And he's currently working on a project that uses low-pass fur filters, to smooth hand controller motion. But it seems like the larger the sample size he uses of the previous position and rotation data, the worse the delay from movement to reflection of the smooth data in VR. So he's looking for any advice on how to smooth touch controller data without the latency hit.
You can't. By smoothing the data, you're introducing latency, and you don't want to do that. Like, in order for your hands to register as your hands, you want those to be as one-to-one with your actual position as your hands as possible. And if you introduce some filtering there, they're always going to be slightly off. And the more the filter you have, the larger the delta is going to become. And the larger the delta gets, the less likely your brain is going to believe that this is the real hands. So we put this like huge amount of effort into the touch controllers to make the latency really, really low. Because what we found is that if the position is not quite right or the latency is a little bit too high, your brain will not buy that these are your hands. And when those things, there's a concept called registration. And registration is when your brain looks to your hands in VR and says, yep, those are totally my hands, and doesn't think about it any longer, just decides that that's what it is. And for that to be true, your hands have to actually be where your physical hands are, because you have other systems like your proprioception system, which is telling you where your limbs are without your eyes. Like if I do this, I can touch my elbow every single time without my eyes being involved with that, because my proprioception system will tell me where my elbow is and where my finger is. So the short answer is don't do that. Do not filter the hand data. The longer, more nuanced answer is, in addition to not filtering that data, you need to be really, really careful that the positions of your virtual hands are absolutely accurate. And the best way that I've found to guarantee that, well, the easiest way to guarantee it is just use our Avatar SDK, which John Barkey was up here a few minutes ago talking about. But our Avatar SDK provides hands, and they're positioned perfectly, and you'll have really good registration with those hands. But if you want to provide your own hands, you need to make sure that the pivots for those hands are right, and they fit your real hand position. My recommendation for doing that is we ship meshes for the controllers, and we also ship meshes for hands. But if you take the controllers and you position them in the world and you get the pivot right, you should be able to like hold the Rift like this and like move the controller in and out, like kind of look underneath the headset, move the controller in and out of VR, and if you got it right, that position will be perfect. It'll look like it's passing through, a line of water into VR and come back out again. And it will look absolutely correct. And if you're wrong, as you go into VR, it'll move somewhere, and that means you don't have it quite right yet. Once you get those controllers positioned properly, you can model your hands around them, and you can do the same test to make sure that your hands and the controllers are positioned where your real hands are. Turns out everybody has like different size hands, so the size of your fingers and things like that are never going to be perfect. But you should be able to. You can use our hand models as a reference because they're kind of an average human size. You should be able to do like this test, where you touch the back of your hand with your finger and it visually looks like you're touching it when you can feel it. And you can do this test, to see if your fingers are not aligned. And everybody who doesn't actually test this stuff thinks that they have their hands right. And we do this test, it looks like this, right? Like it doesn't, it's actually really easy to have it subtly off or not so subtly off. So TLDR, be really careful about where your hand positions are and don't try to filter the output because it'll actually break your hand presence.
Awesome. And Chris, you mentioned our Avatar SDK and John Bartku. As a reminder, you can find our SDK and all of our samples on developer.oculus.com. And John Bartku actually hosted our first AMA on the Oculus forums, so you can hear his responses to some of those questions on our Oculus developer forums. All right. Our next question from social is about time warp and compositor layers. Outside of VR shell apps, do you know of any published titles that have been implementing these two technologies, and do you have any tips for devs trying to work with them?
Sure. So I should probably talk about what time warp layers are. Time warp layers are a system by which you can take a simple mesh, either a quad or a cube map or a hemisphere, half hemisphere thing, and you can allow that to be rendered by time warp instead of by your game engine. So on Oculus platforms, both PC and mobile, you render your eye buffers, you pass them to us in our compositor, we apply time warp to them. Time warp is the system by which we make sure that your head position latency is very, very low, and then from there it goes to the display. In the process of displaying your eye buffers to time warp, we also need to warp them for the lenses, and when we do that, we have the opportunity to composite in some simple object, like a quad or a cube map or something. And the advantage of doing that is there's a couple of different advantages. If you have a high quality texture, either some like high frequency text or like a video or something like that you want to display and make it look as clean as possible, if you display it through time warp, it's only going to get warped one time, because it'll be warped once for the lenses. But if you display it in your game engine, if you just took your like video stream and you plug it on a quad that's sitting in your game engine, it's going to get warped once by the camera, the view projection matrix for your 3D scene, and then it's going to get warped again for the lenses. And each one of those warps introduces a little bit of artifacts. And so you'll degrade the quality just a little bit. So one of the uses of time warp layers is to just keep the quality of some high frequency content that you have by pushing the composition of that down to a later stage of the rendering pipeline. The other thing you can do with it is you can maintain perfect head tracking for this object, either if it's in the world or if it's headlocked. Because time warp is going to render it, time warp renders at 60 frames a second or 90 frames a second, depending on which of our devices you're talking about, regardless of how quickly your game engine renders. So if your game, falls down some horrible performance hole and starts rendering at half its frame rate, a time warp's going to try to fill in every other frame so that the user doesn't notice that the frame rate has died. And the types of things that make it really easy to see that your frame rate is not real is like a head-locked selection reticle. Like when you move your head like this, if you have something head-locked and you're not making frame rate, it will not be smooth. It'll go. And the worst case is when you're like sort of making frame rate but not quite, and then you get like a inconsistent snap from frame to frame. If you take that reticle and you make it a quad and you put it on a time warp layer, it's going to get rendered at 60 frames a second regardless of how quickly your content's being rendered. And so that will always be smooth, even if your eye buffers are updating at a lower frequency. So actually, there's a ton of apps that do this. You just haven't noticed because it's kind of built in and you can't tell when they're being used. I know of all kinds of applications that are doing both the smoothing of the reticle, they're doing layers for high frequency text, and also layers for high frequency video.
Okay. Well, our next question actually comes from Facebook, from one of our members from the Philippines, actually, and is asking about Gear VR and the controller. Have you seen any games that did something really unique with the Gear VR controller?
Sure. So the Gear VR controller is a 3 degrees of freedom orientation remote controller. It has a trackpad on the front of it, and it has a trigger. And it's, we supply this, orientation information. We also supply like a 2-bone IK ARM model. There's been folks that are doing flight control sticks with it. There's a lot of folks that are doing point and click, like laser pointer stuff. I think all that is actually cool. I don't know that you have to be innovative and cool to have a good control scheme. There's a lot of things that have a great control scheme just with point and click. I've also seen some pretty cool stuff that hasn't been released yet that I can't talk about. But I'll tell you what I wanted to make with this controller, which I haven't had a chance to make yet, is I wanted to make like phantasm ball guy. How many people, you know what phantasm, like the tall man, right? He's got this like killer death ball that can fly around, and he just kind of thinks about it and it flies. I think with a 3DOF controller, you could do a pretty good like kill the kids with the death ball flying around controller, and you wouldn't actually show a hand or show the controller. It would be implicit motion, but you would say point in that direction. You'd have an object that's floating in space that would go flying that way, or you say come back this way, and it would come back this way. So it would be a little bit similar to a flight stick, but I think that the feeling of having sort of telekinetic control over this sort of flying orb would be pretty fun and pretty powerful. I haven't tried that yet, but it's something I'd like to see.
Awesome. Quick reminder that we are taking questions from the show floor, so if you have any questions in mind for Chris, please just raise your hand and we'll get to you in the queue. All right, the next question is a little bit more of a personal one. When will Dead Secret Circle be out?
Okay, so Dead Secret Circle, I am in addition to working at Oculus, I'm also the founder of a game developer called Robot Invader. They are currently working on a sequel to the game that they shipped a couple of years ago. That sequel is called Dead Secret Circle. One of the things that I learned in this position at Oculus working with other developers is like the number one rule is that I never reveal another developer's release date. I know a whole lot more than I'm able to talk about publicly, and that extends even to projects that I actually know quite a lot about. So although I'd love to tell you all about Dead Secret Circle, that's actually going to have to be a question for Robot Invader.
Okay, fair enough. Our next question is a two-parter from our forums again, and is about C# job systems and multi-threading. Does the new job system provide significant performance improvements, whether for evening the CPU load or allowing lower costs? And then secondly, are there any other multi-threading optimizations in shipped games that devs can use to improve performance?
Sure. So I think this question is related to the Unity job system work that Unity's been talking about quite a bit. There's this new entity component system that they've just started talking about that is kind of parallel to their existing model behavior system. I think the goal is to be able to allow you to specify your components and your objects in a way that is, by definition, thread safe, so that Unity can then automatically move that between cores. Because one of the challenges that Unity has had on multi-core systems, which include like our mobile VR systems, is that it's been basically single-threaded, and it's been difficult to utilize all of the cores. And also, on mobile chipsets, we have like a lot of cores. The Samsung S8 is I believe it's a 6-core system. Maybe it's an 8-core system. There's a bunch of cores in there that you can actually use if you had perfect multi-threading. Nobody has perfect multi-threading, but I think the goal with this system is to be able to have a higher efficiency across cores than we have today. To answer the question, I actually don't know. I actually haven't had a chance to play with it yet. I think it's actually in pretty early stages if you talk to the folks at Unity. I am cautiously optimistic. It sounds like a really cool thing. In terms of other multi-threaded related optimizations in earlier versions of Unity, generally speaking, the number one thing you want to do for mobile is make sure that multi-threaded renderer box in the player settings is checked, because that actually does most of the multi-threading that you're going to get out of Unity, and it's actually highly valuable. The only reason you would uncheck it is if you're trying to do performance testing and you want to get like a actual reasonable view of where your time's going that isn't interrupted by semaphore locks, basically. And so if you are performance testing, you might uncheck that, but otherwise you definitely always want to have that sort of multi-threaded rendering box checked. Beyond that, I actually don't think you should worry about multi-threading your game code in Unity. And the reason I say that is very, very, very few Unity projects that I've worked with are actually bound on the C# execution time. Usually that part's pretty fast. You may spend a couple of milliseconds at most. Maybe your garbage collection is not great and you're allocating too much memory and you end up spending time in garbage collection. But usually, by a massive amount on mobile, the cost is actually not in executing your game code, but in executing things like draw calls or waiting for the GPU to fill the high resolution display. So multi-threading is not going to help you in that case. If you're worried about multi-threading your game code, that's probably the wrong problem to tackle. And even with Unity's sort of single-threaded thing, you can use things like coroutines to break long work over a period of frames. And that is a pretty reasonable solution in most cases.
Awesome. Our next question is about scriptable render pipelines and lightweight render pipelines. Have you seen any other devs work with lightweight render pipelines, and do you think it has any benefits for Gear VR developers?
Sure, this is another Unity bleeding edge question. So Unity's also working on something called scriptable render pipeline. It's actually in the most recent beta versions of 2018, I believe, where you can sort of control how the render loop works. I actually don't have any experience with it yet. My understanding is that the early versions are focused mostly on PC. I would love to see work on mobile, but I haven't worked on it yet.
Okay. Awesome. Again, remember, we are taking questions from the show floor. Hi. Would you like to answer?
Sure. So the question is, what's the easy way in Unity to get like a reticle texture onto the time warp layer? So we solved that for you in our Unity utils for the Oculus utils for Unity, which is a package you can download. There is a script in there called OVR overlay, and basically you drop that on a quad and you set up some parameters like, do you want this to be world locked or head locked, and you supply one or more textures, and it does the rest. There's a little bit of like, if you want to change that texture, like in particular, if you change that texture every frame because it's streamed from somewhere else, there's an option in there to set. And if you need to like, change that texture at some lower frequency, you might have to go in and code and kick it a little bit to remember to upload the texture. But basically, that's it.
Okay. Are there any other questions from the show floor right now? No? Okay. Our next one from our social channels is about the Gear VR store and using Chromecast to stream from a single eye to your TV. Is there any way we can test that feature when you develop games in Unity?
So I don't think we have a way to easily stream the device out today on a Gear VR headset for customer purposes. But for developers, there's actually a tool on our website called OVR Monitor, OVRC. OVR Remote Monitor is actually the name of the tool. And it is a performance evaluation tool. It's actually a pretty awesome tool, and right now it's in the middle of going through a huge amount of rework. So it's really a tool to keep an eye on. But one of the things it does is it does iBuffer streaming back to your PC. So if you were looking for a way to get a stream of what's going on in the headset for development purposes, I think that's what I'd recommend.
Okay. The next couple questions are from one of our Oculus Start members at home. And this is about Oculus Santa Cruz, Project Santa Cruz. Do you think that there will be any extra trackers for end users to add to various furniture items and help us track those in real-life objects in VR?
Sure. So what I'm going to say about this is Santa Cruz is a prototype. I don't think we're ready to talk about what other types of things we might or might not build with it. Right now, we've been focused on making sure that it's inside-out tracking for your space. And the controllers that we provide is super high quality, and that's where our focus is right now. What we do in the future is not something we're ready to talk about yet.
Okay, I think the next couple of questions that we have here are about Santa Cruz.
Sure.
So
okay.
Given those
Bring them on.
responses, okay. Will Oculus Santa Cruz have out-of-the-box scene reconstruction capacity?
So this question assumes a whole lot about how the vision system on Santa Cruz may or may not work. And I can't really talk about how the vision system works. So what I'll say is today on our prototypes, we do not provide this. It is likely that what you'll see is a API that looks kind of like what we have on Rift. But like I said, it's a prototype. This is the topic of much discussion and iteration right now at Oculus. So I'm not prepared to give an answer.
Okay, and I feel like the same response for the next one about Santa Cruz. Will we be able to use large areas like gyms or hangars for room scale tracking using Project Santa Cruz?
Sure. So this is another one where I get actually asked this type of question a lot. What I would actually encourage you to think about as a developer is not the capability of the device, because the capability of the device is also something that we're still working on. It tracks huge spaces right now really well. I don't know if you try to try it. There's a gigantic room that you can walk around here as part of our demo. But if you made some software that required a gigantic room to walk around, and most of your users at the end of the day wouldn't be able to use your software. I think at the end of the day, probably something that looks like Santa Cruz, some future product that is based on the prototype we have today, is likely going to get used in living rooms. You're going to be putting this on your head and getting up off your couch and playing VR in the largest space you have in your house, which is probably your living room, which is not a gymnasium. So whether or not the device can actually track a gigantic space, I think a more pragmatic answer to this is when you have inside-out tracking that's untethered, you can move around a large space, but you also have to consider whether or not the user is going to have that space available. And I would encourage you to think about ways that you could actually accommodate different size play spaces, whether it's dynamically or through options or whatever. Because if you actually want to sell software to a bunch of users, you'll need to be able to allow, the guy in Japan with a very, very small apartment and the person living, in the hills with this giant room that they built just for VR to both enjoy your software.
Awesome. For anybody just joining us in the Oculus booth, Chris will be also answering questions from the show floor. So if you have any questions, please just raise your hand and we'll point to you and Chris will respond to your question. Oh, and we have a question from the show floor. With Oculus Avatar Hands in Unity, any standard shader transparent objects gets incorrectly occluded when appearing in front of the hands. What's the best shader material to use for something near the avatar hands?
So I haven't actually seen the problem that is being discussed here, but I can imagine that the hands are not sorting well with the rest of the scene. I think you can. What I would like to say is you could probably use any regular shader for these hands. It kind of depends on the effects that you would like to do. For example, we've seen a lot of value in proximity-related effects. As you get your hand close to an object or into an object, it would be nice if the hand becomes transparent, maybe just at the intersection points, so that the user has a spatial signal that their hand has gone close or into a 3D object. And that might require custom shaders that we don't provide. The other thing I want to say is that our avatar system is something that we're constantly working on and we're making improvements to today. So if you have bugs like that you like, we would really like you to actually make a bug report so that we can address them.
Okay. Awesome. Our next question is from one of our VR film producers on our Facebook page. Mm-hmm. What is your stance on 360 video?
Sure. So I think that what we've learned by looking in particular at our Gear VR audience behavior is that 360 video can be super duper compelling and there's a giant audience of folks who really want to consume it. The other thing that we've learned is that it's really hard to make properly. There's all kinds of hard technical problems, like it's difficult to do stitching properly, it's difficult to get a high enough resolution that the little piece that you're looking at in your eye it doesn't look blurry and low res. It's difficult to do spatialized audio. There's all kinds of hard, meaty, great technical problems there that some folks have gotten closer to solving than others, but they impact the overall quality of the experience quite a bit. The main thing is that I think that filmmakers haven't really figured out how to deal with this format yet. I've seen a whole lot of stuff that's cool for 5 minutes, but I wouldn't watch a movie this way. Independent of the technology, I feel like there's a huge amount of creative work that could be done or is being done in this space that maybe hasn't landed in the way that is most effective yet. That I don't know how to do storytelling for half an hour in 360 video, and I think that's a super awesome problem that a bunch of people are trying to solve right now, and I'm super excited to see the result of that, but I haven't actually seen it yet. I've seen some things that are pretty cool, and a lot of stuff that's kind of gimmicky. So I guess my feeling is there's clear audience interest. We see it in the metrics of people going out and watching this stuff. There's some meaty technical problems to solve, but those are just matter of time things. I think the harder problem is the creative piece. How do you make it interesting?
Mm-hmm. Speaking of harder problems and challenges, our next question is about what you think is the most challenging part about being a developer for VR.
I think that's a good question. I'm an engineer. I'm a kind of a game design-y engineer. When I made video games that weren't for VR, that's the kind of video games I made. I think that the most difficult part and the most interesting part is understanding the interaction grammar for VR spaces. And I feel like we have some things figured out, but we have these compared to sort of traditional video games on 2D screens, we have these giant holes in our grammar about how to do even very basic things. It is now 2018, and I've got a pretty good idea of tell you how to walk forward in VR virtually. A couple years ago, I didn't have as good an answer. But that's a really, really basic thing. We have hand interactions now, and we know how to pick things up, we know how to throw them, and we know how to punch stuff. But those are all pretty basic actions too. And I think that the creation of the grammar for interaction in VR is 50% science and 50% art. And we're the folks that are building VR content today are basically writing that grammar as they experiment. And I think it's really, really hard. It's also really exciting. I mean, that's for me why I'm interested in being in this space, is I'm interested in seeing how this grammar is written and maybe influencing it here or there.
Awesome. Well, I'm going to do a quick time check. We are at 12:40. That means we have about 20 minutes left in our session. And we want to make sure we get to any questions on the show floor. Please raise your hand. Let us know if you have any questions for Chris. Okay. Any questions about VR, VR development, mobile VR? Okay, then I do actually have some more questions for you prepared.
Oh, yeah, sure. Yeah. So the question is, what do I think about taking older games that were made for traditional displays and making VR versions of them? I've seen a couple of cases where it worked out really, really well, and I've seen a whole bunch of cases where it worked out really poorly. And I think that the challenge is that the restrictions of VR are completely different than the restrictions of a 2D display. And a lot of the work that you would do to build like a high-end console game, 50% of it doesn't apply to VR. Like when I was building console games, I was spending a huge amount of time on like, how does the analog stick feel, and how does my character's third-person animation feel? And I think most of that's mostly irrelevant at this point in VR. Maybe I can learn some tricks that I might be able to apply to my hand interaction, but the cost-benefit of that investment that was made in the 2D version is not going to apply particularly well to the VR version. In addition, there are a whole lot of games that just aren't going to map at all. Occasionally, there are rare titles that the design of the original title, even though it wasn't for VR, fits into the model really well. At my talk yesterday, I actually showed a shot of a game called Republique, which is a third-person stealth adventure game. And that game actually worked out super well in VR because it actually already used fixed cameras. The whole conceit of the game is that you're looking through a security camera at a character moving in space, and replacing the security camera view with a VR view worked really well. In fact, that game is super awesome. So I don't want to tell you that it's impossible, but the best stuff I've played in VR, with a few exceptions, has been stuff built for VR.
Awesome. Are there any other questions from the show floor? Okay, well, we actually do have some live questions from folks at home on the live stream.
Okay.
Hi.
Great.
What do you see as the big opportunities for Oculus Go apps? Is it social, or is it media, or is it entertainment?
I think the question depends on what the developer is looking for when they say opportunity. I think if you're looking for the most people that you could possibly get in VR, I think entertainment and social are super great ways to do it. We've seen other folks building apps that are inherently social, apps that have, avatars with VoIP in a shared space. This is clearly super compelling. We think it's going to be all over the place in VR. Yeah, it's actually something that we're pushing really hard to get into VR. If you build it today, the total number of people with headsets in the world is small enough that you're going to have a pretty tight-knit community, and I think that is a difficult community to monetize. Like if your goal was to make revenue, if that was your definition of success, maybe that's not your first choice. I do think that Go is going to be fantastic for that type of application, and there's a whole lot of folks out there whose initial goal in VR is not immediate revenue. For those folks, I think things like video, things like entertainment, and things like social are super great fits. I actually think social will become incredibly profitable in the near future, but I can't say that about it today. The other thing that I would say is that games are a standard. I think they do really well. People expect to be able to play games on these devices. They work really well for games, and it turns out that like in the pantheon of developers in the world, game developers are kind of the experts on making real-time 3D worlds. So some of the highest quality experiences of any type we have are games. I want to highlight one or two others, though. I think travel applications are going to be a big deal. And I also think that there's something to space exploration, whether it's a game or not, and maybe meditation. And this is based on what I think we've seen successful on Gear VR. And we think that an audience for Oculus Go is similar, but more focused and more interested in a high-quality experience. So if the definition of success is large impact and revenue, I would say go for something that looks like that. Games, maybe travel, maybe space exploration or something.
Okay, awesome. For anybody just joining us in the booth, we're here with Chris Pruett, our head of development engineering, to answer questions live on the show floor. So please raise your hand. Let us know if you have any questions about VR development or about Oculus. Oh, I think we have another question. Okay.
Sure. Questions about QA, which devices? Sure. So specifically for desktop. Okay. Yeah, so the question is recommendations for QA, particularly for a small studio doing desktop VR. What I would say is the desktop platforms seem to be pretty stable. They're also not very variant, right? Like you've got Windows of a couple of different flavors, and you've got video cards of a couple of different flavors. Particularly if you're building in something that's already been tested at the engine level, like Unity or Unreal, your risk is pretty low, and I think most folks get away with only a little bit of QA. But what I was going to recommend is that we've actually just published to our website hardware stats about our user base. So what you should probably do is go take a look and see what users are actually using, and then focus in on those things. I think what you'll see is there's a whole lot of Windows 10 out there. There's quite a bit of NVIDIA cards. Please keep in mind our rec spec. But I would do a targeted series of tests against the devices that are most valuable to users today.
We actually do have a couple more questions from folks at home on the live stream. What type of apps can run on Santa Cruz? Is it more like Gear VR or Rift?
So somewhere in the middle. The thing about Santa Cruz is it's very difficult to explain how high fidelity it is without actually putting the headset on. And one of the problems that we've had when thinking about it ourselves is the way that you build a PC application is very different than the way that you build sort of a mobile application. But both types can produce an incredibly beautiful, incredibly high-end image. So if you have seen the Santa Cruz demos today, they look a whole lot more like Rift apps than they do like Gear VR games. In fact, I think that most of the folks, if you put that headset on their head and you didn't tell them that it was a standalone, wireless, all-in-one headset, they would believe that they're using a Rift. I think that the target for quality is going to be a lot closer to what we see on Rift than it is what we see on Gear VR. The way that you build that software will be a little bit different, but the target and the user expectation is going to be fairly high-end.
Okay. Are there any other questions on the show floor for Chris?
Sure. What are some of the best applications of statistical inference or machine learning used in Gear apps? I have no idea. That's a great question. I don't know.
Okay. I have another question for you from our live stream. What are the hurdles of convincing larger AAA studios to develop for VR rather than as a novelty add-on after the fact on a game?
Sure, that's a great question. So I would say that we've had some great success with some very large AAA studios. I mean, if you look at like Ubisoft, they've made huge investments in VR. I think that when you talk about the sort of upper range of video games, those are companies that are working against very, very, very expensive software, and they're expecting a very, very large return. And even when I worked in console video games, games that had a pretty reasonable projected return, got canceled left and right, because if it's not a 10x return, or if it's not, hundreds of millions of dollars of revenue, then it's really not worth their time. And I think that basically there are some companies that are willing to do some experiments, and some companies who are willing to get into a vertical early. I think we've seen that with Ubisoft in particular and a couple of others. And then the companies who are like, we experiment when it gets a little bit bigger. And I think that's fine too. But I also think that the folks that are in now, as I said earlier, have the opportunity to write the grammar and have the opportunity to build the skill set that they need as the total number of devices in the world scales.
Awesome. We actually just got another question on the live stream, which I think correlates with something we heard on the floor yesterday, which is about fixed foveated rendering and the Oculus Go. So is Oculus Go development mostly the same as Gear VR?
Yes, so Oculus Go uses the same SDK, uses the same Unity integration, uses the same Unreal integration as our Gear VR stack. And in fact, Gear VR applications run on Oculus Go for the most part. So development is almost exactly the same. For things like fixed foveated rendering, that's really just a switch that you flip. You turn it on, you tell us how much on you want. There's a couple of levels, and it's sort of automatic after that. And you can adjust it if you need to turn it down or turn it up. You have some API to adjust it, but it's very simple. For things like that, even if you call that API on a Gear VR, it just wouldn't do anything. So in that particular case, you can just basically throw it in there and produce an application that would run both on Gear and on Go without any subsequent modification. There's some other areas where we think it'd be, you actually will want to make modifications to the content just for Oculus Go. Like, for example, if you're showing the controller, you probably don't want to show the Gear VR controller to the user who's in an Oculus Go headset. But if that user is using the same application and they're on Gear VR, you're going to want to show them the Gear VR controller. So we ship the models for both. If you're using those models as the controller in your scene, you're probably going to want to select one and turn the other one off based on the device. And we have documentation that's coming pretty soon that will talk about how to do that. But basically, you can consider these two devices as very, very similar. The areas that they're going to differ are sort of how you communicate with the user, and also so the upper bound for performance, I think, is going to be higher on Oculus Go.
Awesome. Are there any other questions on the show floor? Again, we're here with Chris Pruett. He's our head of development engineering relations at Oculus. Okay, then we do have another question from the live stream.
Okay.
Will Oculus consider providing photorealistic assets for free or for purchase that are exclusive for games that are on Oculus?
I don't know the answer to that. It would not be my call to make. My expectation is we probably would not do something that is exclusive to our platform. I mean, my team's goal as part of the content team is to make our developers successful. And if that means that we want to provide things that are going to help them build their businesses on top of VR, not just necessarily lock them into our platform. So I don't know. We may provide some sort of assets in the future. I don't know the answer to that. I don't think that we would provide them with restrictions.
Okay. All right. Is there anybody on the show floor that has questions for Chris? Well, I do have some more questions prepared for you. If you don't mind.
Let's do it.
This next one is actually from Reddit. How is fixed foveated rendering fast if it has to render tiles separately?
Yeah, I had like 3 people ask me this yesterday. I showed a picture. I don't know how many of you saw it. I showed a picture at my talk yesterday about how fixed foveated rendering works. And the idea is, you render the center of the eye at a higher resolution than the edges of the eye. And as you get further and further towards the edge of the eye, you render at a lower and lower resolution. And that is hard to perceive because that happens in your peripheral vision, and also because the lenses warp the pixels that are on the sides of the eye buffer anyway, so you don't have a lot of fidelity there to begin with. And the question was, well, but doesn't that require you... And I showed a picture that was like tiles of different colors that had different resolutions set to them. And the developer came to me and said, well, don't I have to render all those tiles at a different res in order for that to work? And what I realized is I hadn't actually explained sort of one of the fundamentals of how mobile graphic chipsets work, is that most of them are what we call a tiled renderer. And that means at the hardware level, what they do is they take the scene that they're about to render and they automatically cut it up into tiles. So generally, there's a little bit of variation depending on which vendor we're talking about, and not all mobile chipsets work this way, but mostly, you can expect that a mobile renderer, you submit a bunch of draw calls. It takes all those draw calls and it does a pass over all the geometry. And what it's doing when it does that pass is it's cutting the geometry up. It's projecting it into space, figuring out where that geometry is going to be in the scene, and then it's cutting it into tiles that are in screen space. And each one of those tiles, the triangles get subsorted for the opaque geometry anyway, so that the triangles that are actually going to turn into pixels are known, and those that are going to get completely occluded get rejected. So the total number of triangles that need to get processed gets reduced by that first pass. And then the second pass is it goes over all those tiles, and it has this list of triangles that it needs to render, and it actually does the rasterization for each of the tiles, usually in parallel. So the whole hardware, the way that it renders the scene, is to cut the scene up into these tiles, and then render them in parallel, and do some occlusion of opaque triangles while it's at it. And that's how these chipsets have been able to crunch through really large numbers of triangles while staying within sort of the heat and battery requirements of a phone or of a mobile some other sort of mobile device. We are leveraging that existing system to cut things into tiles. And what we're doing is we're actually saying, this particular tile, I just want you to render to a lower res output. And this tile over here, I want you to render to a high resolution output. And this one over here is going to be super duper low res. And that's actually just a setting on the hardware and not something that the game developer has to think about. Game developer continues just to render its scene the way that you do normally. When it gets down to the hardware level, the hardware goes, oh, I'm on tile 34, and I know that's supposed to be at half res, so I'm going to output a buffer that's half res. And that just happens in the hardware. This is not something that we could have done on our own. We worked really closely with Qualcomm to get this to work for the Oculus Go, because it does require a pretty deep dive all the way down into the hardware. But that's how it works, and that's why I showed that image with those tiles that were different colored. The short answer, the most important part is this is essentially free. There's no work incurred in cutting up the scene into tiles, because the hardware has to do that already. And also, the developer doesn't have to change anything. We can do it to existing applications that were written years ago for Gear VR that with no concept of this by turning on a flag in the driver. So this isn't something that the developer will have to go out and either spend extra cost to render extra tiles or think about cutting the scene up themselves. It's all pretty much automatic.
Okay. Quick time check. We have about 5 minutes left. So if you have any questions on the show floor for Chris Pruett here, Head of Development Engineering Relations at Oculus, please raise your hand now. We'll get to them as soon as possible. Anybody?
So the question was, last year we saw some GPUs that were revealed that were desktop GPUs but were based on tile-based. Would this work on those devices as well? I think that's your question. I mean, maybe. I think so. I don't know. I don't know the answer specifically for our implementation of this particular technology. I think in theory, whether it's in a desktop machine or in a mobile device, any GPU that is already based around a tiling format, in theory, if it's built with this sort of ability to render at different resolutions, maybe that would be possible. I don't know the specifics.
Okay. And I just got a check from the side. We have time for one more question. Is there any questions on the show floor? No? I actually do have one more question.
One more?
For
All
you.
right.
What is developing for Oculus Go like, and how easy is it to port from Gear VR?
Sure. So you don't have to port from Gear VR. Your Gear VR application runs on it already. There's a few caveats to that. If you had dependencies against things that only phones have, like you need the camera, or you have a 2D interface that doesn't work in VR, then that's not going to work. But other than that, most applications just run on it without any modification. I would say development for this device is very, very similar to development for Gear VR, again, because it's the same SDK. It's basically the same, Android operating system running under the hood. You plug it in via USB. One of the really nice features is you can have it plugged in while you're developing, which has been kind of a pain point for Gear VR developers. It's not been possible to keep the device plugged into your computer while also being in VR. And that's something that Oculus Go corrects. So you could have the headset on your head, have a little USB cable coming down to your computer, and be doing your performance profiling in real time as you look around, which is something that's been possible on Gear, but has been challenging. But otherwise, it's very, very similar.
Okay, and I think that's it for us today. I think we're all out of time.
Cool.
Thank you, everybody on the show floor and at home on the live stream for submitting your questions. And thank you, Chris.
Thank you very much for coming.
Us.
Appreciate it. And thank you, Allison. Thanks.
All right.